presenting this work. This is something that I'm a software engineer at a company called Helix. We're a bunch of devs and UX people that help get startups off the ground. And this came out of a problem that I noticed, well, came out of an opportunity that I noticed. So just to give a little bit of background, this idea of modeling user flow is what I'd call a simple idea. It's one of these ideas that you come across and you go, surely this exists in the world already. And I've had this experience before where you see the simple idea. It's obviously correct, but it's not everywhere. And when I come across these ideas now, I pay more attention. And so I work with user experience designers and with end customers, and there are these times that come across where you try to convince the customer that no, your flow of your application should just be different, and that's kind of like, look, we've argued about this too much, just leave it as it is. And you kind of, oh well, we're heading down a track where we know we're going to have to revisit screen flow, etc. So the idea was to build a system that simply modeled user flow. The core idea is to model user flow, and the idea is to have something that could literally be full life cycle development. Everything from, instead of pencil and paper with a user experience person sitting with a customer, to that point, all the way to scaling and production monitoring, etc. So it's based on the key idea is based on some state machine description, and I'll get to a demo quickly. So just the one single idea was to model user flow throughout the entire life cycle, and then all sorts of other things kind of crept in, and liveness is one of those things that crept in. So it's not nearly as live as it should be. It's not nearly as live as it could be, but it's still in its early days. So one of the other things that crept in was this analogy to Christopher Alexander that a city is not a tree. He goes on to say it's a semi-lattice, a tree. We're talking about computer science tree. And if we look at it, application development is not a tree. The view that that designers have. Over here, designers are, pineapples, versus mechanics being, software engineers have. They're two totally different views of what's going on. And one of the things is even though they might be viewing the same thing, different aspects of it are projected. And at different points in time, what might be valid for a designer might not actually yet be valid for an engineer. And kind of from the keynote point this morning, it should be valid. It doesn't matter that it's incomplete from a production system point of view. It's kind of, it should still be valid. And so one of the ways to kind of think about this is to say, well, actually what the designer is interacting with is a model, whereas what the developer is interacting with is a program. And I'm going to use the definition from Lehman as the difference between them. And the difference between them is that a model never actuates. You never actually put a model into the real world and have it do things. You only ever inspect it to inform your opinion. Whereas programs actually get embedded in the world. And one of the things that Lehman pointed out was that programs actually affect their own requirements because they get embedded in the world. So just before jumping into a demo, kind of just give a broad outline of kind of the layout of what we're going to see. So in the center, we've got a flow specified, state machine specified, and each of the boxes, it's a bipartite graph. There are two types. There are places and there are transitions, and there are arcs that go between them. Now, places are given extra information. They're given a specification in an algebraic data language, and transitions need to have transforms. And just picked a transform language that works. I've used a little language called JSON8, but ideally it would be its own kind of transform language. Okay. So, and then the stuff on the right-hand side where you've got the run section is swapping into a live mode. So currently you're either in kind of development mode or you're in a running mode. Okay, so let's jump to a demo. Okay. So this would kind of be the view that a designer might interact with. So what you could come and do is let's create a new one, and we're going to have these things called these places. Now, if you take a look at a lot of the petri-net modeling tools, for instance, they'll have different types of places. They'll have places for continuous data, and they may have places for discrete data. Here, we've got a number of different types of places that a developer might interact with. We have places that are modal and that act like screens, and we have places that are more like petri-net non-deterministic places where you would squirrel away data. But from a designer's point of view, you really are only going to interact with screen places and user transitions. From a developer's point of view, there are going to be multiple transitions. And we've done something that you wouldn't do that isn't valid in kind of petri-net world, where we've drawn some connection between two places. And from a designer's point of view, these are variants of a screen. So what we might have done here is we may have gone and said, well, this screen is our login screen. And then we've got a transition that's going to go to one of two places. And so it says, well, actually, you've got two actions over here. Are we going to jump to maybe the dashboard screen, or if you took a different path through it, you could jump to an error state, a state with error login. And now let's just go and briefly define some data schemas for this algebraic data language. So we might have a username and these algebraic these algebraic types that we can define, they have automatic rendering, screen rendering. So we can get a screen built for us, kind of auto-generated. What you can then do is, once you've gone through and you've decorated this to some, to a degree, there is a component, a piece of it which is a plugin to Figma. And then from here, we can actually push these to Figma, and it kind of uses best practice Figma design, where it's building a component library and then using that component library to build screens. The particular modeling, the algebraic data language that we're using has got an annotation ability. So to express anything that you can't express simply in the language, you can specify as kind of typed as structured comments, and that could be used for things like specifying screen size or specifying extra information that isn't captured and isn't necessarily directly for defining flows. If we were to swap to a developer mode, and I'm going to bring up a pre-canned one, what you're going to do is you're going to swap out the user interactions, the user transitions that got specified by the designer for some sort of form of subcomponent. Now, in a lot of the petri-net literature, there's this idea that as soon as you add modularization, you actually increase expressiveness. And so most petri-net modeling environments do not have any form of abstraction, any form of modularization. Now, one of the things that kind of snuck in actually very early on was this idea that we're going to need some form of abstraction, some form of modularization. And so what we've got over here is more like what the developer would see, and that variant that we had before, where we had two places that were actually variants of each other, they get collapsed down to one place with extra fields in there. In this particular case, the field that we've added has to do with error messages. So in the designer's case, they might have had a username, and in their error screen, they might have had a username and error message. Over here, in the developer point of view, those two data schemas have been combined into one that would satisfy that screen in multiple states. So from a designer's point of view, we're talking about variants, and from a developer's point of view, we're talking about states. And if we go through, this little one, then we're going to be going through. We're now in a live execution mode, and we're the places that are marked as red are the current active places. Anything that's been marked in green is your program trace. And there's a bunch of stuff where you can actually go and interrogate the transitions that it made, why it made those transitions, etc. Just like to kind of finish off to say this is very early work. I kind of think it could belong in live more than it currently does. It does have some live aspects to it. The transition code is very similar to what you might do for having migration code. If this is going to be a true live environment, then migration becomes important to say, look, not only is it valid for this current instance, but as I change it, you may need to add code that migrates current data from one version to another. So thank you for allowing me the opportunity to present this. Yeah.
Thank you, Gary.